Welcome to the Easy Access 1 Project J1A. Project J1A is to build a feature-rich, multi-threaded, Java-based email proxy filter from scratch. Welcome to Chapter 3. We're going to go over multi-threading. Hopefully at this point in time you've been through Chapter 1 and 2. We left you Chapter 2 with the completion of a client program. The client program opens on a port and accepts a connection, a socketed connection from a client of your choosing. I use the Telnet client, as you will have seen. Now, the program is essentially useless at this point in time if you have more than one person wanting to talk to you. Right now, you would simply open up the port by running the program, and you would connect to it with either a Telnet session or another PuTTY session or Telnet or any socketed communication client. That's very nice. Get one, and then we're terminating. The case for multi-threading is very clear. If we're going to have a server, and if the server is going to service the internet over TCP/IP, you have to have an open socket for every client that wants to connect. This means we're going to have to create a loop, and we're going to have to create a loop that spawns a Java object. And we're going to create that Java object, and we're going to alter the proxy controller class. I'm going to get rid of the conversation manager. I'm going to create a proxy thread class, and I'm going to implement the Java thread object to create a new thread so that the client is separated and has their own existence. And then as soon as we get into multi-threading, historically it's going to come up very quickly that we're going to run out of system resources if we don't watch what we're doing, because there's only so many sockets, there's only so much memory in each computer. I don't care how big the server is, you can crash it with system memory allocation. You can definitely crash it with socket allocations if you're not careful. So let's get into it. We left off with this code right here. You'll see that let me get that centered right for you so you can see a little bit more what's going on. I've enlarged the font size for you guys so that anyone with a iPhone or a S7, S6 up to tablet size can actually see the code. I was worried in Chapter 1 that the font size was a little small. First thing I'm going to do is I made a small error here, which maybe some of you more advanced guys will notice, as I created this while loop. And in this while loop, it's going to max out a CPU because there's no pause in the system thread. So the proxy controller needs to have a slight timeout here in this, and let me see if I can find it for you guys. Sorry about the delay. So I'm going to add this line here in which I take thread, and when you take thread as its face value, it becomes the current operating thread. Thread sleep 10 milliseconds. So when we get caught in this loop, the system doesn't expend all its resources trying to loop through as fast as possible. Small catch, but you get up to 10 threads and you're looking at system crash without pausing the thread, at least just for 10 milliseconds on each loop, which should take your CPU consumption basically down to 0. Good trick, good to know. There's probably an even more efficient way of doing this. I'll leave that to somebody else out there who's done quantitative analysis on this. I've done some pretty good analysis. This one works pretty good. Okay, now I don't like Conversation Manager. Convo Manager is too limiting to me. It runs, and it is part of this class. I'm going to comment out the entire Conversation Manager at the moment, and I'm going to use my spiffy little tags. Hopefully you guys will move on to become great programmers if you aren't already, and I'll see some code someday that will have my little personalized end method, end class, end if, end while, EW, and I'll see them out there and know at least that I did some good. All right, so I'm going to comment out the entire conversation manager, and as well as the socket that calls it, or the method that calls it. And here we go. We're going to start our multi-threading application, and I'm going to start with the creation of a new thread. So I'm going to create something called proxy thread, and proxy thread st socket thread equals new proxy thread. And that, of course, is going to be very upset because I don't have a proxy thread class yet, but I'm going to. I'll leave that just for a second. And then I'll have thread proxy thread equals new thread st. Okay. Sorry guys, I don't even know how this got allowed to happen, but I don't want to use proxy thread. I'm going to just go with thread instance thread equals new thread st. That the compiler shouldn't have even allowed that, but which is fine. Probably because they have so much in common. Proxy thread is this, and I'm going to add proxy thread dot start. All right, now let's get into Runnable. Runnable is an implementation that a object can implement in Java, and in order to implement Runnable, they have to provide a run method. So we know where we're going with this. I'm going to create a new class called proxy thread, and then I'm going to create a new thread called instance thread, and I'm going to add the object proxy thread st into the instance thread. All right, I know that sounds confusing. I'll go over it one more time. I have a proxy thread called st, and I'm going to create a new system thread and add the proxy thread to the system thread. So this forces the system to call a separate thread for me. Okay, so I won't, you see, most people would say, oh, you're going to call run, right? Because that's the method. So you actually call start, and start instructs system at some level to go call the run thread in your class. Okay, so confusing a little bit, but this is how they implemented it. So I'm going to go ahead and create a new class called proxy thread. Okay, part of proxy package, new class proxy thread, and I'm going to implement Runnable, and it's going to get upset about that because of capital R, and we're going to get them implements expected and implements. There we go. So it's going to give me an error. If I hover over here, it's going to cry saying that the run method hasn't been public run. How about that? And what is it, void? It's probably going to have to be void. And with the addition of that function right there, that method run, suddenly Eclipse is happy again. Open up this, and you'll see the proxy controller is good, and it's getting upset about this. And that is because I've used the wrong variable name. This is going to be my instance thread. And suddenly everyone's happy. Okay, now let's get over to proxy thread, and I'm sure some of you have guessed, I'm going to take the entire functionality here of my old conversation manager. I'm going to copy that. Let's Control-C it. And that I'm going to put inside for simplicity's sake, inside my run. And I'm going to have to load my imports. I have to do my imports and my favorite string module that you saw me do in chapter 1 or 2. Okay. And we're going to have, if you'll remember, we had the keyword s, the variable s, and that's going to be a socket. Okay. Hope I haven't lost anybody yet. Their socket is defined, and we're going to define our own socket over here. So now the functionality that was in my conversation manager, I have now created a new class. I have stuck all the stuff we worked on in chapter 2 into it. You're welcome to rewind this and watch what I did really quick there, because it kind of got through it fast. But so now we have essentially the same functionality that we had earlier, but now I have created a new class, a runnable class, and this is a threaded class, a multi-threaded class. In order to truly multi-thread this, I'm going to have to set up a while loop. And I don't want to call this conversation manager anymore because that's done. So now we're going to call it proxy thread. Call it class or module, which is fine, right? So while we're here, let's go clean up this proxy controller. We had a whole bunch of commented out code, which I already borrowed and copied. So we'll get rid of that. Now you can all use your own personal way of keeping track of these threads. There's a thread management, a thread group class that you can use. I will be using the thread group class later on, as I plan to. But for the moment, let's just cough up an integer, and we will use an integer to figure out how many connections we have, or at least the order of connections as they've come in. So I'm going to create a private integer called ID, and I'm going to set it equal to 0. And that's going to be in my proxy controller. So here, and this would be where the socket is created, and here's where we create a class to adhere the new thread. This new socket, st, which is my proxy thread, dot s equals s. Okay, so what this is going to do, I don't know if yes, the s, the public socket s exists in the proxy thread. So I'm simply going to pass the object that was created in the server accept. The socket object will now be passed into the proxy thread. Okay, and I hope you're holding on to your hats, because now I'm going to assign the identity plus ID. And if you don't know what plus plus means versus ID plus plus, or equals plus or plus equals, if you don't know that stuff, you need to go review how the auto incrementation works in Java. So I'm going to add 1 to the ID. I'm going to use the current value and then automatically add 1. If you do anything in Java, if I used ID plus plus, then I would end up with a 0. But if I do plus plus ID, I should start with a 1. Okay, so I could base 0 this or base 1 it that way, whatever. Proxy thread doesn't have my integer yet, so let's head over here, and it's getting upset because it doesn't have an identity ID, and I'll give it its own private ID, and I should make that a public integer ID, and it's automatically going to be equal to 0. Okay, so over here in the proxy controller, you'll notice my error just went away. Just a quick review. We're going to create the server socket. It'll hang right here. The system itself will hold it right here, waiting for someone to connect or telnet in. If they do, we'll create a proxy thread class. This proxy thread class is over here. We'll have the system instance thread created. We'll assign the proxy thread class to it. Before we leave, we'll make sure we'll pass off the socket that was created, and an identity number. And that's going to be auto-incremented number. And then we will instruct the system to start the new thread. And the new thread will be started by calling the run inside the proxy thread. I'm sorry if I'm moving right along. It's complicated. You're welcome to scroll back and go through it again. All right. So now we should be beginning the execution of the run module. Now we have about a good opportunity to put this in the right spot. That thread sleep was in the wrong spot. It really should be right below the while would be a better spot for it. Otherwise, you're only sleeping on when the instantaneous moment that someone actually connects, which wouldn't help you at all. So we're going to go with this. I'm going to change the logging a little bit. So instead of saying port open at, I just want to change this to a client connected as ID number and then the system current time in milliseconds. Okay. And I'm going to change the logging at the end here to say client, use the client number so I can identify who is connecting and who, and I don't really care what the message length right now. Okay, so we now have our proxy thread class, and this will be called in a multi-threaded session in its own thread. We're going to call the input stream for that particular socket, and then we're going to follow the logic the same way it was rolled out in chapter 2. Okay, end class, and then I have, you notice I'm using my extraordinary method of tagging these curly brackets, and I'm guessing that that's just going to be an extra curly bracket. And we should be passing the compiler more or less. Now let's get into the actual threading, or the actual creation of a second thread. This will be the first time we have a program that will recognize more than one thread. So we'll do a while true. This is a bad idea, but you're welcome to come up with some other kind of control logic. I'm fine with it. And we're going to end curly bracket and jump ahead, and I will label my end while. So now I've created a true loop that cannot be escaped without terminating the JVM, and we will continue to create new sockets based on the current server, and these new sockets will have a new thread created and will be passed off just this identity. This is where you have to be careful, because you're kind of losing your grasp on this object as it gets spun off. You would create some sort of a callback. If you need to continue to control this object from the proxy controller, then you're going to need to create an array of a thread group array so that you can keep track of your threads, or you're welcome to create your own. You could extend thread group into something that you want. I use statistical objects that I'll create that contain various quantitative measures as to how much data, who it's connected to, the IP addresses, and those objects I will create and overload into some GUIs, possibly in this project. I haven't decided if I really want to take you guys down the JSwing road or any of the AWT toolkit archaic stuff. And I don't even know if that really matters to you. If you're going to make an email proxy server that's going to allow you to manipulate the email systems as they come in before they get to the email system, whether that's something you need to do or not, it's up to you. So while I'm here, let me clear this out. One thing I want to add, which I didn't really add last time, is that we need to do a little bit better cleanup of the socket object. So after we know for sure that the client is disconnected, I'm going to create my own little special close for the socket. So the s.close, and in case it has a failure, which is fine. At this point in time, I'm okay with an empty curly bracket. This is probably not the smartest thing in the world to do, but calling socket close and having a failure on socket close is perfectly fine, because at this point in time, we're headed out anyway. There's really no logic past this. So let's rev up the engine here for you, and we will see what we see. I'll bring up the debug panel. So I'm running the loader. Loader is running the proxy controller. The proxy controller is sitting right here at server accept. It is waiting for someone to connect. When someone connects, we're going to create a socket from the server socket, and then we're going to create a thread. We're going to assign the socket, we're going to assign an identity number, and then we're going to get the system to create a new thread and thread it out for us. Over in the proxy controller, we'll set the module name. We'll create the same logic that we had in chapter 2, and I've created here, let's review. I had a line that caught the enter key, so I'm just simulating the concept of text going back and forth, and I've got some quit logic here with telling me what was said, what the message was, and that the client has disconnected, and then we're going to close the socket. So here we go. I have a telnet session here. I'm going to create telnet localhost 25. As you'll see, the client connect number 1, you'll see on my console, and I'll type something. Hello, Dolly, with a bunch of Y's. Enter. Character code 13 was detected. The message was printed out here on standard out, and the client, since I used character code 13, was disconnected. And you'll notice that command functions were returned to the command prompt right here. Now, that's cute. Let me show you what happens. We will do, let's start a new start CMD. If anyone doesn't know what start CMD does, it creates a new console window for me. Okay, so I have 2 console windows now. So in the first console window, and one of the console windows, I'm going to telnet localhost 25. So now I have two clients connected to my single-use, my multi-threaded code, which previously was a single-use code. Type something, client 3, and there was a 20-second timeout, so he was terminated as well. He had 20 seconds to do something. And that 20-second timeout was discussed in chapter 2, and it's settable right there. You don't have to use it, but otherwise you really have no real good control long term. So let's get into something that's even smarter. Test.bat. I created a batch file, and take a guess what's going to be in the batch file, guys. The batch file is here. That's right. I have approximately 50 or so commands using the start. If you don't know, you're welcome to go into your terminal sessions and your command line prompts. Start basically just creates, it's a good way of batch coding threading. So I'm going to execute this batch file, which is going to connect to my little server that I've created here about 52 times. You ready? Let me clear this. And test.bat. There she goes. Woo! And you notice we connected about 50 times or so. We started at connection number 4 since we're auto-incrementing. And I'm not going to do anything. I'm just going to wait. I'm going to say someone's attacking, and they've created 50 connections, and you're going to watch them all disconnect. And there they all go. So now I've created a multi-threaded client that can handle all the system resources you can throw at it. There's no upper limit to the number of connections that this could handle. You could create something to throttle the sockets. I would caution you to do that, because if you have someone connecting in trying to transmit mail to you and you don't have a socket open, they're only going to give you so much time before they're going to put you on a 4-hour delay or some sort of a time delay to connect later. But email systems are pretty resilient like that. Okay, let's go over a PowerPoint. We made the case for multi-threading. We make the case to get rid of the conversation manager. I've created a proxy thread class, and I've enabled the capacity to connect to this state, this particular program that we have at this point, this Java project, up to 50 times. I made a good case for that. We've done a good job, and we're going to make sure we keep an eye on our objects to make sure that our objects are eliminated. You could even go so far as setting s equal to null on the way out, which gives the system garbage collector an advantage there. So join us for Chapter 4 when the link becomes available, where we will start to talk to an Exchange server, and we're going to start to review SMTP commands, and will give us an insight into how to control the information and how to presuppose what's going on and how to get ahead of some spammers and how to protect your email server against some of the nasties on the web.